Before we start today's independent practice, I just want to talk to you really quick about the difference between factor and rate. So factor is just exponential growth or decay factor. It's just b. Okay, so it's whatever is attached to your exponent x. So in f of x equals 2 to the x, your growth factor is 2. Okay, now rate is going to be the percent that you are above or below 100%. Okay, so let's look at this. In example 1, for f of x equals 45 times 1.02 to the x. 1.02 is the growth factor. That's b. Okay, but if we want to talk about the growth rate, that's going to be different. Okay, that's where we're going to take 1.02 and write it as a percent. So that takes that decimal point, moves it 2 over, and that's 102%. Now the rate is how far above or below 100 you are. So for this, we're 2% above 100. So the rate is 2% growth. Growth because it's over 100. 2% is how far above 100. Okay, so this is the difference between factor and rate. The factor for this is 1.02. The rate is 2%. Okay, let's look at example 2 really quick. So for this one, it's 0.75. 0.75 is the factor. However, that is 75%. And that is below 100. So if I subtract, it's going to give me 25. So my rate is 25% decay. Okay, now that we have that, let's look at today's independent practice. So for number 1, all exponential functions are in the form y equals a times b to the x. What values of b make it an exponential growth function? So if b is greater than 1, anything above 1 is going to give us growth. Now for decay, it's not just below 1, but it's between 0 and 1. So we would say b is greater than 0 and less than 1. Okay, so now that we have that, let's go ahead and just sketch an exponential growth function. Yours is going to look somewhat similar to mine, but it doesn't have to be precise. So I'm just going to draw mine where it's going to skate along here and then just hop right on up like that. And then decay is just going to go ahead and do the opposite thing. Not anything special or terribly difficult about that. Okay, label each function as exponential growth or exponential decay. For A, it is decreasing, so that is decay. This one is going up, so this is growth. This one's going down, so this is decay. So far, so good. Okay, for number 4 at the bottom, it says to label each function as either exponential growth or exponential decay. Now, for this y-intercept, this initial value 2.4 at the beginning, doesn't matter to us. The thing that I care about is what is inside the parentheses. That is a 3. It is greater than 1, so this represents growth. For B, we have 0.98. That is less than 1, so that is going to be decay. Let's see, for C, 5 halves. So this one's a fraction where the bigger number is on top. 5 over 2 is the same as 2 and a half, which is greater than 1. So this is going to represent growth. If your fraction in here, if your factor is a fraction that is improper, meaning the bigger number is on top, that's going to mean growth. All right, let's see. For D, 1.45 is greater than 1, so that's growth. E, we've got a fraction again, 2/7. The larger number is on the bottom, which means this is less than 1, so this is decay. And then last one, 1 over 9, again, fraction with the larger number on bottom, so that's also decay. All right, let's flip this over and look at the back. Number 5, given the equation y equals 35 times 0.57 to the x, does this represent growth or decay? 0.57 is between 0 and 1, so this is going to be decay. The decay factor is this decimal, so it is 0.57. But the rate of decay, that's where we are going to take 0.57, write it as a percent. Then I am going to subtract it from 100. So this is equal to 43. So it is a 43% decay rate. The initial value is the very first number outside the parentheses, so for this it is 35. Okay, number 6. Given the equation y equals 1.3 to the x, we could rewrite this as y equals 1.3 in parentheses to the x. So 1.3 is greater than 1, so this is growth. The growth factor is 1.3. 1.3 can be rewritten as 130%, which is 30% growth. And the initial value here, there's nothing attached to this base. There's nothing in front of the parentheses. There's nothing else. So the initial value here is just 1. Okay, last one, number 7. Given the equation y equals 1.4 times 1.03 to the x, this represents growth. The growth factor is 1.03. The growth rate is 3%, and the initial value is 1.4.